Hello students, this is our fifth lecture of Ionic Equilibria. In last lecture, we have seen about the hydrolysis of salts. Firstly, we have discussed about what is the definition of hydrolysis of salt or what is the meaning of hydrolysis of salts. As we know, hydrolysis means the breakdown of water and the salt molecules, or we can say ions of salt, that means cations or anions, or both ions, if these ions are reacts with the ions of water, so it produces either acidity or alkalinity. Then this type of process or this type of reaction is called as the hydrolysis of salt. So on the basis of that, we have discussed about the four types of hydrolysis of four types of salts. One is salt of strong acids and salt strong bases. In that we have taken NaCl as an example of strong as a salt of strong acid and strong base. Acid is HCl and base is the NaOH. So whenever it undergo NaCl is undergo ionization, as we know, in the form of Na plus and Cl minus ion, and these Na plus and Cl minus ions, if it reacts with the water, it produces strong acid HCl and strong base NaOH. And as we know, these strong acid and strong bases doesn't undergo means it doesn't remain in the form of HCl and NaOH. It easily undergo ionization because it is a strong electrolyte. So that's why it immediately convert into a Na plus and Cl minus ion. So in this way, we can say there is no hydrolysis takes place. So the pH of the concentration of hydronium ion and the concentration of OH minus ion is not disturbed and solution remain in neutral form. In second case, we have taken salt of strong acid and weak base. Copper sulfate is used as a salt of strong acid H2SO4 and weak base COOH by 2. As we know, the part of weak component is undergo hydrolysis and the part of strong component doesn't undergo hydrolysis because of it convert if the part of strong component, either base either acid, if it undergo hydrolysis or if it undergo reacts with the water, it forms strong electrolyte, either base either acid. So it immediately converted into ion, so that's why इनका hydrolysis नहीं होता है. But the part of weak component, like here COOH by 2 का Cu, if it is reacts with the ions of OH minus ions of from water, it forms COOH by 2, and the COOH by 2 is a weak component, so it remain in the form of COOH by 2 in aqueous form, right? So in the form of turbidity it is obtained. To remove the turbidity, we have to add concentrated H2SO4. That means addition of concentrated H2SO4 would be required. In third case, the salt of weak acid and strong base, we have taken sodium acetate is a salt of weak acid, acetic acid and strong base NaOH. So in this case, acetate anion reacts with the ions of water because Na is the ion of strong base. So as we know, strong base अगर है तो उसका ion water के साथ react होता है, it produce NaOH and NaOH is a strong base, so that's why it undergo ionization immediate. So that means Na का hydrolysis नहीं होता है. So बचा कौन है? Acetate anion, and acetate anion is the part of weak acid. So it reacts with the ions of water and produce acetic acid. Acetic acid as a weak acid, so it remain in the form of acetic acid with OH minus ion. So the concentration of OH minus ion increases in the solution. So the solution, become a basic in nature. Okay. So in last case, we discuss about the salt of weak acid and weak base. Here, Ba is used as considered as a salt of weak acid Ha and weak base POH. It undergo ionization, and these two ions are from the weak part, So that's why both ions are reacts with the ions of water and produce BOH as a weak base, HA as a weak acid. So here there is no any formation of OH minus ion and H2O positive ions in the reaction. So that's why the concentration of OH minus ion and the concentration of H3O positive ions remain same. It does remain same. So that's why the solution is neutral in nature. In case of what? In case of salts of weak acid and weak base. Okay. So the solution, for example, ammonium acetate is the salt of weak acid and weak base. So weak base is NH4OH and weak acid is acetic acid. So whenever it is whenever it reacts with the water, that means it undergo hydrolysis, so forms acetic acid and ammonium hydroxide. So the solution may turns out acidic, basic or neutral. It is depends on the relative strength of weak acid and weak base, which is formed in the hydrolysis reaction. Okay. So इसी को हम लोग कंटिन्यू करने वाले in this lecture. So if consider Ka, as we know, the K is the dissociation constant of weak acid and Kp is the dissociation constant of weak base. We already discussed that in lecture number 2 in Oswald dilution law, right? K is the dissociation constant of weak acid and Kb is the dissociation constant of weak base. So there are 3 cases. First case is if Ka, that means dissociation constant of acid is greater than the dissociation constant of base. Then in that case, what will be the nature of solution? So if Ka is greater than Kb, the solution will be acidic in nature. That means if the dissociation constant of acid is greater than the dissociation constant of base, the solution will be acidic in nature. In other case, that means in second case, it's vice versa. If the dissociation constant of acid, that means Ka, is less than Kb, it is less than the dissociation constant of base. So what will be the nature of solution? The nature of solution will be basic in nature. Okay, will be basic. That means here Kb is greater than Ka, na? Ka is less than Kb, that means Kb is greater than Ka. So dissociation constant of base is greater than the dissociation constant of acid. So in that case, solution will be in basic in nature. And if both dissociation constant, that means dissociation constant of acid and the dissociation constant of base is equal, then in that case the solution will be in neutral in nature. Okay, then how this acidic, basic and neutral solution forms, which we'll discuss in this way. First we use the salt of weak acid and weak base for which Ka is greater than Kb. Okay, so ये जो weak salts है, means salts derived from weak acid and weak bases, these are divided into 3 types. अब वो कौन से 3 टाइप्स है? बेसिकली सॉल्ट्स तो रहेंगे पार्ट ऑफ वीक एसिड एंड वीक बेस, बस उसमें भी सबसे वीक कौन है, सबसे कम वीक कौन है? On the basis of that, these salts are divided into 3 types. First one is the salt of weak acid and weak base for which Ka is greater than Kb. Second one is the salt of weak acid and weak base for which Ka is less than Kb. And third one is the salt of weak acid and weak base for which Ka is equal to Kb. Now first, let us discuss about the first salt, that means salt of weak acid and weak base for which Ka is greater than Kb. What it is meaning? Here Ka, that means dissociation constant of acid is greater than the dissociation constant of base. Means we can say that the value of Ka is greater than the value of Kb. So if this type of salt is there, then what will be the nature of solution? So see, as you can see on the screen, NH4F, that means ammonium fluoride, is used as a salt of weak acid HF and weak base NH4OH. So both are the weak acid and weak base. Okay. The value of Ka means the value of dissociation constant of HF acid. ठीक है, ये जो Ka वैल्यू दी हुई है ये किसकी है? वीक एसिड HF की है, मतलब डिसोसिएशन कांस्टेंट ऑफ HF की है. What is this? It is about 7.2 into 10⁻⁻⁴. And the value of Kb is the dissociation constant of base. किसके लिए? NH4OH के लिए. How much? 1.8 into 10⁻⁵. So in Ka value here 10⁻⁴ is here, and in Kb 10⁻⁵ is here. Which one is greater term? This term, that means 10⁻⁴ is greater term than the 10⁻⁵. Okay, so that means Ka is greater than Kb. Okay, so ये कौन सी वैल्यू होगी? 0.00007.2 और ये होगा 0.00001.8. Okay, so that means this value is greater now. So Ka is greater than Kb. Now this salt is undergo hydrolysis. फर्स्टली तो उसका कन्वर्जन होगा आयोनाइजेशन में. किस फॉर्म में कन्वर्ट होंगे वो आयोनाइजेशन होता है? तो NH4 पॉजिटिव and F माइनस, राइट. फर्स्टली इट अंडरगो आयोनाइजेशन लाइक दिस NH4F, it undergo ionization. What will be the product? Product is NH4 positive and another one is F minus, that means fluoride negative. Okay, so these are this is the possible products. These are the possible products. Now this is an aqueous media, so these two ions, that means ions of salt, reacts with the ions of water. Now as we know, जो वीक का पार्ट रहता है, वीक कंपोनेंट का पार्ट रहता है, वो इजीली अंडरगो हाइड्रोलिसिस होता है. सो इन दिस केस बोथ एसिड्स एंड बेसिस आर वीक. अब उसमें भी सबसे जो वीक वाला होगा ना, वो ज्यादा रिएक्ट होगा किसके साथ? वाटर के साथ. और जो कम वीक है वो कम रिएक्ट होगा. अब ये जो वैल्यू दी है K और Kb के, ऑन द बेसिस ऑफ दैट वी कैन से दैट Ka of HF is greater than the Kb of NH4OH. Means on the basis of that we can say that the HF is less weak than NH4OH. Hydrogen fluoride is less weak than ammonium hydroxide, or ammonium hydroxide is more weaker than hydrogen fluoride. और जो सबसे वीक को रहता है उसका ज्यादा हाइड्रोलिसिस होता है. सो लेट्स सी व्हाट हैपन हियर. NH4 positive ion and F minus ion both are undergo hydrolysis and we get this NH4OH and HF molecule. Both are weak base and weak acid. Okay. This hydrogen fluoride acid is slightly stronger than the base NH4OH. जैसे अभी मैंने आपको बताया. On the basis of that, these values K and Kb, we can say that this hydrogen fluoride acid is slightly stronger than the base NH4OH. That means NH4OH is weaker than HF. So the two ions reacts with water as. अब जो वीक रहेगा वो ज्यादा रिएक्ट होगा वाटर के साथ, और जो स्ट्रॉन्गर रहेगा वो कम रिएक्ट होता है वाटर के साथ. सो NH4 पॉजिटिव आयन, अब इसको हम लोग सेपरेटली रिएक्शन में बताते हैं. NH4 पॉजिटिव आयन reacts with water, produce NH4OH plus H3O positive ion. Similarly, fluoride ion reacts with the water. It produces hydrogen fluoride with OH minus ion. So by using this sentence, the NH4 positive ion produce H3O positive ion. So as we know, NH4 positive ion is weaker than the HF. So that's why NH4 positive ion more reacts with the water and more produce hydronium ion. राइट। सो ये ज्यादा कॉन्सेंट्रेशन रहेगा हाइड्रोनियम आयन का, और फ्लोराइड आयन थोड़ा सा स्ट्रॉन्गर है तो कम रिएक्ट होगा, तो OH माइनस आयन का कॉन्सेंट्रेशन H3O पॉजिटिव आयन से कम होगा, राइट। So if the concentration of hydronium ion is more, so what will be the pH, what will be the nature of solution? It may be acidic in nature, right? So see क्या है आगे, ये बराबर है या नहीं, तो see here the NH4 positive ion hydrolyzes to a slightly greater extent than fluoride ions. As I told you earlier, the NH4 positive ion is a weak than fluoride ion. That means NH4OH is a weak than the fluoride ion. So that's why जो weak रहता है वो ज़्यादा hydrolysis होता है. So NH4 positive ion hydrolyzed to a slightly greater extent than fluoride minus ion. So that means the reaction first means what? This NH4 positive ion with water produce more H3O positive ion than the reaction second, which produce OH minus ion. Okay, so that means NH4 positive ions are slightly stronger than the as an acid than F minus ion as a base. Hence, more the concentration of hydronium ion is present in a solution. So that's why the nature of solution become acidic in nature. And if we use blue litmus paper, then whenever it is deep into this solution, it turns red. Okay, blue litmus paper turns red. So likewise, we can say that if the value of Ka is greater than the value of Kb, in that case, the solution, the nature of solution is acidic in nature. Okay, so this is the first case. Now in second case, that means salt of weak acid and weak base for which Ka is less than Kb. That means the value of dissociation constant of acid is less than the dissociation constant of base. So यहाँ पे अब value of Kb is greater, right? And the Ka is smaller. So take one example. Ammonium cyanide, NH4Cl, is a salt of weak acid. Which weak acid? HCN, hydrocyanic acid or hydrogen cyanide. Having a value of Ka is 4 into 10 raised to the power minus 10. And weak base NH4OH. Kb, that means dissociation constant of base, is 1.8 into 10 raised to the power minus 5. Okay, showing that Ka is less than Kb. Yes, here 4 into 10 raised to the power minus 10, and in case of Kb 1.8 into 8 into 10 raised to the power minus 5a. That means this value is greater than this value, or this value is less than this value. Ka is less than Kb. Okay, so we are taken example as a NH4Cn. Now whenever this NH4Cn is dissolved in water, it hydrolyzes into this. We get NH4OH and HCN. NH4 positive plus Cn minus ion both react with the H2O, produce NH4OH and HCN. Now ये जो रिएक्शन है इसको हम लोग सेपरेट स्टडी करते हैं कि हाउ दिस रिएक्शन प्रोड्यूस दिस NH4OH and HCN minus ion, HCN ion, or sorry, molecule. Now this base NH4OH जिसकी Kb की वैल्यूज ज्यादा है than Ka. On the basis of that, we can conclude the value of Kb is greater than the value of Ka. So we can conclude the NH4OH is just slightly stronger than the HCN, right? NH4OH as a base जो है वो थोड़ा सा ज्यादा stronger होगा HCN से, that means hydrogen cyanide से. So hydrogen cyanide weak है, and as we know जो weak रहता है उसका हाइड्रोलिसिस ज्यादा होता है, करेक्ट? सो यहाँ पे देखते हैं आप लोग. So this base NH4OH is slightly stronger than acid HCN. So these two ions reacts with water. Which ions? NH4 positive and Cn minus ion reacts with water. So NH4 positive react होगा water के साथ तो क्या produce करेगा? NH4OH produce करेगा with H3O positive, H3O positive, right? And Cn minus ion reacts with water. वाटर के साथ रिएक्ट हो रहा है, मतलब कौन से आयन के साथ रिएक्ट हो रहा है? कैटायन रिएक्ट होगा एनायन के साथ, एनायन रिएक्ट होगा कैटायन के साथ. सो ये एनायन है तो यहाँ के कैटायन कौन सा होगा? H+, राइट. तो बचा कौन? OH माइनस आयन. OH माइनस आयन एज अ प्रोडक्ट मिलेगा. सो यहाँ पे Cn माइनस आयन रिएक्ट्स विद द HCN एंड प्रोड्यूस OH माइनस आयन. On the basis of value of Ka and Kb, Ka is less than Kb. So that means Cn minus ion reacts more with water and produce more OH minus ion because HCN is slightly weaker than NH4OH, or NH4OH is slightly stronger than HCN. So Cn minus ion hydrolyzed to a slightly greater extent than NH4 positive ion. So this reaction, this second reaction produce more OH minus ion. That means in solution, the concentration of OH minus ion increases than the concentration of hydronium ion. So the nature of solution become basic in nature, slightly basic in nature. And the litmus paper test करते हो तो the litmus paper, which litmus paper? The red litmus paper turns blue because of slightly basic nature of solution. Which solution? Ammonium cyanide solution. Understood? So this is the second case of weak acid and weak base, in that the value of Ka is less than Kb. And in third case क्या है? Salts of weak acid and weak base for which Ka is equal to Kb. Okay. Now here the value of Ka and the value of Kb both are same. And if both are same, then what will be the nature of solution? So see, in that case, ammonium acetate is used as a salt for weak acid. Weak acid कौन सा? Acetic acid. Having a value of Ka is 1.8 into 10 raised to the power minus 5, and weak base NH4OH, again Kb value is 1.8 into 10 raised to the power minus 5. So both values of Ka and Kb are same. For acetic acid as well as for NH4OH, value of Ka and value of Kb are same. Okay. So same में मतलब no one is stronger, no one is weaker, right? So when the salt of ammonium acetate is dissolved in water, it hydrolyzes as. जैसे इसको हम लोग वाटर में डिसॉल्व करते तो उसका कन्वर्जन होगा CH3CO नेगेटिव एंड NH4 पॉजिटिव. सो ये जो दो आयंस रहेंगे, एसिटेट आयनाइन एंड अमोनियम आयन, वाटर के साथ रिएक्ट करो, क्या होगा? इट प्रोड्यूस एसिटिक एसिड and ammonium hydroxide. Both are weak acid and weak base. So इसका अभी हाइड्रोलिसिस हम लोग सेपरेटली देखते हैं. This acetate anion reacts with the water. अब इसमें से मतलब किसके साथ रिएक्ट करेगा वो? एक है अपना H+ और दूसरा आयन रहेगा अपना OH-. तो ये H+ के साथ रिएक्ट करेगा because this is anion and this is cation. So it produce acetic acid. और ये बचा कौन है? OH- आयन, जो कि अपने को प्रोडक्ट में मिलेगा. Similarly, NH4 पॉजिटिव कैटायन, अब ये किसके साथ रिएक्ट करेगा? वाटर के एनायन के साथ. एनायन कौन सा? OH- anion, right? So this NH4 positive reacts with the OH- ion from the water, produce NH4OH and hydronium ion. That means ये H+ रहेगा और दूसरे वाटर मॉलिक्यूल्स के साथ कंबाइन करके अपने को मिलेगा हाइड्रोनियम आयन. Now by using these values of Ka and Kb, we can say that the value of means the nature of acetic acid and NH4OH both are same, right? No one is stronger, no one is weaker. So that means both hydrolyze in a similar manner and both produce OH minus ion and hydronium ions having a concentration same. किसी का concentration ज़्यादा नहीं है, किसी का concentration कम नहीं है. OH minus ion जितने produce हो रहे उतने ही hydronium ion produce हो रहे. That means concentration of both OH minus ion and hydronium ion are same. So the nature become neutral in nature. So as Ka is equal to Kb, the relative strength of acid and base produced in hydrolysis is same. Okay, relative strength of acid and base produced in hydrolysis is same. So reaction first and second occur to a same extent. As I told you earlier, the concentration of OH minus ion produced and the concentration of hydronium ion produced are same. Okay, so hence the solution of as ammonium acetate is neutral in nature. So blue और रेड लिटमस कोई भी लिटमस पेपर यूज करते हो तो देयर इज नो एनी एक्शन ऑन litmus paper because of solution is neutral in nature, in which case in the value of Ka and the value of Kb is equal in that case. Understood? So this is all about the salts of weak acid and weak base for which Ka is greater than Kb, Ka is less than Kb, and in third case Ka is equal to Kb. Okay, if Ka is greater than Kb, then what will be the nature of solution? The nature of solution is acidic in nature. In case of Kb is in case of Ka is less than Kb, the nature of solution basic in nature. And in case of Ka is equal to Kb, so the nature of solution is neutral. There is no any change on the pH. So there is no any change on the litmus paper. Okay. So this is all about this salts of weak acid and weak base. Now the next topic is common ion effect. This is very important effect. Okay. Basically, this topic is means you can say that ये जो टॉपिक है कॉमन आयन इफेक्ट ये आपके स्टेट बोर्ड के सिलेबस से रिमूव किया गया है. ठीक है, रिड्यूस किया गया है. बट मैं इसलिए पढ़ा रही हूँ आप लोगों को बिकॉज दिस इज वेरी इंपॉर्टेंट टॉपिक टू अंडरस्टैंड द अदर टॉपिक्स. ओके, सो लिसन केयरफुली. Common ion effect. The word itself gives its meaning. Common ion, right? Common ion. Ions दो types के होते हैं. One is cation, another one is anion. So maybe cation common हो सकता है या anion common हो सकता है, but कोई तो भी ion common होना चाहिए in two species. So if this term, the common ion effect, is used to describe the behavior of solution containing to dissolve solutes that have one of the ion, cation or anion common is called common ion. What is the meaning of common ion? कि ऐसे दो solutes से okay, two different solutes say which contain one of the ion is common. Okay, for example, ठीक है, example हम लोग बाद में देखेंगे. या sodium acetate and acetic acid. Acetic acid and sodium acetate दो different components है. Acetic acid में acetate anion common है और sodium acetate में acetate anion common है. So एक दोनों मॉलिक्यूल में दोनों स्पीसीज में आयन कॉमन है. विच आयन? एसिटेट आयन. सो हो गया कॉमन आयन, राइट? सो व्हाट इज द मीनिंग ऑफ कॉमन आयन? नॉट इफेक्ट. कॉमन आयन, द सॉल्यूशन कंटेनिंग टू डिसॉल्व सोल्यूट्स that have one of the ion is common, either cation or anion, whatever may be, is common, that is called as common ion. Now this common ion effect is the special case of Le Chatelier principle. Now in this case आप सभी लोगों को पता होना चाहिए कि what is the meaning of Le Chatelier principle. In last year you have already learned about that. ली चैटेलियर प्रिंसिपल अगर किसी को याद नहीं होगा तो आप 11th का बुक ओपन करके इन केमिकल इक्विलिब्रिया उसमें चेक कर सकते हो. ठीक है. सो दिस इज द स्पेशल केस ऑफ ली चैटेलियर प्रिंसिपल इन विच क्या बोलते हैं ली चैटेलियर प्रिंसिपल. whenever the stress is applied to an equilibrium system is an increase in the concentration of one of the product. What is this meaning? If the reaction is in equilibrium, okay, consider reaction is in equilibrium. So if by any type of component stress is released or stress is applied on one side, either product side or reactant side, कोई भी एक साइड में अगर कोई स्ट्रेस अप्लाई होता है मतलब कॉन्सेंट्रेशन ऑफ आयंस इंक्रीज होता है और कोई स्ट्रेस अप्लाई होता है, सो इन दैट केस क्या होता है, इन दैट केस द रिएक्शन, in that case the equilibrium get disturb. okay, equilibrium क्या हो जाएगा, disturb हो जाएगा. so the reaction having a tendency to get back to equilibrium condition acquire. और क्या करेगी रिएक्शन, रिएक्शन इक्विलिब्रियम को फिर से अक्वायर करने की कोशिश करेगी. एक तो रिएक्शन को फॉरवर्ड करेगी या तो फिर रिएक्शन को बैकवर्ड करेगी, डिपेंड ऑन द side or stress is applied. okay, so this is called as the Le Chatelier principle. now the effect of stress is reduced by shifting the equilibrium to the reactant side. अगर प्रोडक्ट साइड में स्ट्रेस अप्लाई हुआ है तो अपनी रिएक्शन रिवर्स बैक जाएगी और इक्विलिब्रियम अचीव करने के लिए रिएक्टेंट साइड में रिवर्स बैक जाएगी. ओके, और अगर स्ट्रेस रिएक्टेंट साइड में अप्लाई होता है तो इक्विलिब्रियम अचीव करने के लिए रिएक्शन गोज फॉरवर्ड. ओके, अकॉर्डिंग टू विच प्रिंसिपल, अकॉर्डिंग टू Le Chatelier principle. So in common ion effect we have to study about the principle of Le Chatelier principle, Le Chatelier, because this whole common ion effect is depend on the Le Chatelier principle. So listen carefully and this is very very helpful to understand the other topics जो अभी हम लोग आगे पढ़ने वाले हैं. उसके लिए important बहुत टॉपिक है, इसलिए मैं अभी आप लोगों को पढ़ा रही हूँ. ओके, so now consider the solution of weak acid. Which weak acid? Acetic acid, and another one is its soluble salt is sodium acetate. मतलब एक एसिटिक एसिड है और उसी का एक सॉल्ट है सोडियम एसिटेट. ठीक है, मतलब ये कैसे तैयार हुआ होगा सोडियम एसिटेट, एसिटिक एसिड रिएक्ट्स विद NaOH, प्रोड्यूस सोडियम एसिटेट. So here acetic acid is the weak acid and its soluble salt is sodium acetate is taken as an example. Now this acetic acid is a weak acid, so it dissociates very slightly because in whole ionic equilibria हम लोग किसके बारे में बात करते आए हैं, weak acid weak base, weak acid weak base, and weak acids are dissociates very slightly. We already discussed that in lecture number 2, in lecture number 1, right? So these weak acids is undergo dissociation very partially, very slightly, in smaller extent. Okay, so that's why here this reversible arrow is present. Okay, so this acetic acid is undergo dissociation, produce acetate anion as well as H plus ion. Another component is its salt, sodium acetate. Now this sodium acetate is a strong electrolyte because ये कैसे तैयार हुआ है, इसको हम लोगों ने तैयार कैसे किया था, एसिटिक एसिड कैसे तैयार किया था उसको, एसिटिक एसिड reacts with acetic acid reacts with sodium hydroxide and one of the component is strong, acetic acid is weak, no doubt, but the sodium hydroxide is a strong. So one of the component अगर strong है तो उसका जो उससे बनने वाला जो component रहेगा उसको as a strong electrolyte consider किया जाता है. Correct? So this sodium acetate is a strong electrolyte, or as we know, strong electrolyte dissociates almost completely. Up to 99% it dissociates completely. Okay, so the sodium acetate is a strong electrolyte which dissociates almost completely. In aqueous media, so see the reaction. This sodium acetate is dissociation in the converted into acetate anion and Na plus ion. Okay, so this is the partial dissociation, and in second case complete dissociation takes place. In first case this is weak acid, so it dissociates partially. In second case it dissociates completely. So because of strong electrolyte it dissociates completely in same chamber. Okay, in same reaction. मीन्स ये जो हो रहा है ना एसिटिक एसिड का डिसोसिएशन और सोडियम एसिडेट का डिसोसिएशन हम लोग सेम चेम्बर में ले रहे. नाउ व्हाट यू कैन से दैट फ्रॉम टू रिएक्शंस, from these two reactions we can say that the both reaction produce acetate anion. क्या दिख रहा है दोनों रिएक्शन में कॉमन? इन बोथ रिएक्शन this acetate anion is a common term. Correct? This acetate anion is a common term. That means we can say that this is the common ion. बरोबर? So this is the common ion. अब ये जो common ion है दोनों रिएक्शन में, इसका इफेक्ट क्या होता है सॉल्यूशन पे, उसका भी देखते हैं हम लोग. Let's see. So this common ion, the concentration of this acetate anion in second reaction is more because dissociation is complete. Correct? तो यहाँ पे इसका concentration ज्यादा है than this reaction. So ये इसका concentration और इसका concentration same ही है ना, same in the sense दोनों आयन same है, तो मतलब ये इसका concentration और इसका जो भी मोल्स रहेगा वो दोनों के एडिशन करके बहुत ज्यादा अमाउंट में मोल्स तैयार होगा. सो दिस फर्स्ट रिएक्शन इज गेट डिस्टर्ब, क्योंकि ये जो एसिटिक एसिड है ये वीक एसिड है. ठीक है, अब अपने को पता है कि 5 मोल कंसीडर कि यहाँ से अगर 100 मोल या 10 मोल मैंने लिए, ठीक है, 10 मोल ऑफ एसिटिक एसिड इज टेकन, एंड बिकॉज ऑफ दिस इज वीक एसिड इसमें से सिर्फ 2 मोल अगर डिसोसिएट हो रहे, 2 मोल्स डिसोसिएट हो रहे. ठीक है, अब ये 2 मोल्स तो हो गए. अब आ गया अपना सेकंड कंपोनेंट, दैट मींस सोडियम एसिटेट. अब सोडियम एसिटेट मैंने लिए थे 10 मोल्स सिमिलरली. अब बिकॉज ऑफ दिस स्ट्रॉन्ग इलेक्ट्रोलाइट उसका पूरा का पूरा डिसोसिएशन हो गया. कंसीडर करो कि 9 मोल हो रहे, ऑलमोस्ट कंप्लीटली, मतलब 9 मोल डिसोसिएट हो गए. तो ये 9 मोल और ये 2 मोल दोनों मिलके कितने हो गए? 11th मोल. राइट, 11 मोल हो गए ना. सो 11 मोल मतलब क्या, इक्विलिब्रियम डिस्टर्ब हो जाएगा ना फर्स्ट रिएक्शन का, क्योंकि फर्स्ट रिएक्शन का एम क्या है, ओनली 2 मोल को प्रोड्यूस करना, वो तो 9 मोल ज्यादा एक्सेस में आ गए यहाँ पे. सो ये रिएक्शन तो पूरी हिल गई, इक्विलिब्रियम हो गया डिस्टर्ब. इक्विलिब्रियम डिस्टर्ब हो गया तो यहाँ पे स्ट्रेस कौन से साइड में रिलीज हुआ है? कॉन्सेंट्रेशन ऑफ एसिटेट आयन इंक्रीज हुआ है. दैट मीन्स स्ट्रेस इज अप्लाइड ऑन प्रोडक्ट साइड. स्ट्रेस कौन से साइड में अप्लाई प्रोड्यूस हुआ है? प्रोडक्ट के साइड में प्रोड्यूस हुआ है स्ट्रेस. और ली चैटिलियर प्रिंसिपल क्या बोलता है कि जिस साइड में स्ट्रेस अप्लाई होता है या प्रोड्यूस होता है उसके अपोजिट साइड में अपनी रिएक्शन जाती है टू अचीव ए इक्विलिब्रियम कंडीशन, बिकॉज रिएक्शन हैविंग ए टेंडेंसी टू गेट बैक द इक्विलिब्रियम कंडीशन. ओके, अब रिएक्शन को इक्विलिब्रियम अचीव करने के लिए क्या करना पड़ेगा? सी, sodium acetate dissociates completely, so produce high concentration of acetate ion. ओके, जैसे सेकंड रिएक्शन में concentration ज्यादा था, एग्जांपल लिया था 9, राइट. According to Lee Chatterjee principle, the addition of acetate ion from sodium acetate to the solution of acetic acid shifts the ionization equilibrium of acetic acid from right to left. From right to left. Thus, the reverse reaction is favored in which acetate anion combines with the H plus ion to form unionized acetic acid. Thus, the reverse reaction is favored in which acetate ions combines with the H plus ion to form unionized acetic acid. अब ये कैसा? See, in this reaction, as I told you, this 10 mole is taken, okay, and here 2 moles are only dissociates. So ये भी 2 मोल है और ये भी 2 मोल होगा, ठीक है. और in second case 10 mole is taken, excuse me, sorry, here 9 mole, almost completely बोल रहे तो 9 mole dissociate होगा, ओके. तो ये भी 9 मोल होगा, इसका कुछ रोल नहीं है, फिर भी लिख लेते, ओके. सो इन फर्स्ट केस 10 मोल इज टेकन एंड इक्विलिब्रियम कंडीशन कहाँ अचीव हुई है? 2 मोल एसिटेट एनायन पे इक्विलिब्रियम कंडीशन अचीव हो चुकी है. अब ये खुश है, डिसोसिएशन हो गया, भले ही स्लाइटली हो गया, भले ही पार्शियली हो गया. दिस रिएक्शन इज वेरी हैप्पी इन दैट केस. अब आ गया सोडियम एसिटेट इन सेम सॉल्यूशन, and because of this sodium acetate, it is strong electrolyte, it dissociates almost completely. 10 mole is taken, उसने अब तैयार किया है 9 mole of sodium acid, सॉरी एसिटेट एनायन. अब ये भी कॉमन है किसके साथ? इसके साथ. तो ये 9 मोल और ये 2 मोल कितने हो गए? 11th मोल. 11th मोल हो गए, मतलब क्या है? कॉन्सेंट्रेशन ऑफ एसिटेट आयन इंक्रीजेस ऑन प्रोडक्ट साइड. ये एसिटेट आयन का कॉन्सेंट्रेशन बढ़ गया है ना, कितना हो गया? 11 मोल हो गया. दोनों कॉमन आयन होने के कारण दोनों रिएक्शन का कंबाइन होके एक्स्ट्रा बढ़ गया. सो ये रिएक्शन में अपने को चाहिए था पहले इक्विलिब्रियम अचीव करने के लिए 2 मोल, तैयार हो गया 11th मोल, तो इक्विलिब्रियम तो हिल गया ना, इक्विलिब्रियम हो गया डिस्टर्ब. अब ली चैटेलियर प्रिंसिपल क्या बोलता है कि जिस साइड में अगर स्ट्रेस अप्लाई होता है या तैयार होता है, प्रोड्यूस होता है, उसके अपोजिट साइड में रिएक्शन जाती है टू अक्वायर और टू अचीव द इक्विलिब्रियम कंडीशन. तो यहाँ पे कौन से साइड में स्ट्रेस रिलीज हुआ है, प्रोड्यूस हुआ है? ऑन प्रोडक्ट साइड, बिकॉज एसिटेट आयन, concentration of acetate ion is increases, correct? So to achieve the equilibrium condition for this reaction, for first reaction, ये एसिटेट आयन क्या करेगा? रिएक्शन गोज रिवर्स बैक ना, रिएक्शन गोज रिवर्स बैक म्हणजेच काय कि जो 11 मोल, जो 11th मोल रिएक्शन मिक्सचर में एसिटेट आयन है उसको कम करना है. तो कम कैसे करेंगे? ये एसिटेट आयन कंबाइन होगा H प्लस आयन के साथ. एसिटेट आयन कंबाइन होगा H प्लस आयन के साथ, तो क्या प्रोड्यूस करेगा? अनआयोनाइज्ड एसिटिक एसिड. सो रिएक्शन गोज रिवर्स बैक ना. ली चैटेलियर प्रिंसिपल यही बोलता है कि जिस साइड में स्ट्रेस प्रोड्यूस हुआ है, रिएक्शन उसके अपोजिट साइड में जाती है टू रिमूव द स्ट्रेस एंड टू गेट रिएक्शन इक्विलिब्रियम रिवर्स बैक, राइट? सो दिस एसिटेट आयन कंबाइंस विद द H प्लस आयन. जितना H प्लस आयन होगा उसके साथ एसिटेट आयन कंबाइन होके रिएक्शन गोज रिवर्स बैक. रिएक्शन गोज रिवर्स बैक म्हणजेच काय, मतलब क्या कि एसिटिक एसिड में उसको कन्वर्ट करना, जो कि अनआयोनाइज्ड स्पीसीज है. एंड अनआयोनाइज्ड स्पीसीज में कन्वर्ट करना, दैट मीन्स its dissociation is suppressed, its dissociation is decreased. So this is the effect of common ion on, this is the effect on reaction. Okay, understood? क्या हो रहा है कि the stress is produced on product side because of this common ion. According to Le Chatelier principle, because of stress produced on right side, ठीक है, this is the right side. So to acquire or to reverse, to get back the equilibrium condition, reaction goes backward. Reaction goes backward means right to left अपनी रिएक्शन प्रोसीड होगी and we get unionized acetic acid molecule. That means we can say that the dissociation of acetic acid suppressed or decreases or suppressed by the common ion. Okay, this is called as the common ion effect. So see here, according to Le-Chatelier principle, the addition of acetate ion from sodium acetate to the solution of acetic acid, it shifts the ionization equilibrium of acetic acid from right to left. Right to left. Thus, the reaction goes in reverse, and which is favored, in which acetate anion combines with the H plus ion to form unionized acetic acid. And this unionized acetic acid तैयार होना मतलब क्या है कि उसका आयोनाइजेशन को कम करना, उसका आयोनाइजेशन को सप्रेस करना. Hence, the dissociation of acetic acid is suppressed due to presence of, it is suppressed due to presence of, this is very important statement, due to presence of acetate, due to presence of sodium acetate containing common ion. Which common ion? Acetate ion. Okay, because of that common ion, the dissociation of acetic acid is decreases or is suppresses. Okay, so the common ion effect states that the ionization of weak electrolyte is suppressed in presence of strong electrolyte containing a common ion to the weak electrolyte. What is the meaning of this statement? Common ion effect कहाँ पे show होता है? In the ionization of weak electrolyte. Weak electrolyte मतलब weak acid, ठीक है, और weak base, कुछ भी हो सकता है, weak acid भी हो सकता है, कुछ weak base भी हो सकता है, ठीक है. द आयोनाइजेशन ऑफ वीक इलेक्ट्रोलाइट मतलब वीक इलेक्ट्रोलाइट का, वीक एसिड हो या वीक बेस हो, उनका आयोनाइजेशन को सप्रेस किया जाता है किसके प्रेजेंस से? बिकॉज ऑफ द प्रेजेंस ऑफ स्ट्रॉन्ग इलेक्ट्रोलाइट. कौन सा स्ट्रॉन्ग इलेक्ट्रोलाइट? विच कंटेन द कॉमन आयन. किसके साथ? वीक इलेक्ट्रोलाइट के साथ. फॉर एग्जाम्पल अभी देखा हम लोगों ने एसिटिक एसिड और सोडियम एसिटेट. एसिटिक एसिड क्या था? वीक इलेक्ट्रोलाइट था. सोडियम एसिटेट क्या था? स्ट्रॉन्ग इलेक्ट्रोलाइट. दोनों में कॉमन टर्म कौन सी थी? एसिटेट आयन कॉमन था. ठीक है, तो अगर ऐसी केस है तो वहां पे कॉमन आयन इफेक्ट अपना इफेक्ट शो करता है. तो हाउ विल यू स्टेट्स दैट कॉमन आयन इफेक्ट? द आयोनाइजेशन ऑफ वीक इलेक्ट्रोलाइट इज सप्रेस्ड इन प्रेजेंस ऑफ द स्ट्रॉन्ग इलेक्ट्रोलाइट which contain an ion common to the weak electrolyte. Understood, students? So because of that common ion, the dissociation of weak electrolyte is suppressed by the presence of common ion. Okay, according to Le-Chatelier principle, this whole and soul takes place. Okay, so this is called as the common ion effect. I hope सबको समझ में आया होगा common ion effect क्या है. This is very important. So this is all about the common ion effect. Now in next lecture we will discuss about the buffer solution and afterwards solubility and other term is that means solubility effect. Okay, so that we will discuss in next lecture. Till then, stay safe and stay at home. Thank you, students.